Significant digits. When reading the meniscus of this graduated cylinder, I can read with certain that it's at 6.6 milliliters. However, the bottom of the meniscus is just barely above that hatch mark, so I'm going to have to guesstimate the other number. I read this meniscus as a value of 6.61 milliliters. That is the preciseness of this graduated cylinder can read the values of the liquid in it. We use significant digits because the different pieces of equipment that we use while conducting experiments will give us different decimal values. Let's say I had a piece of solid and I placed it on this top scale right here, the analytical scale, and let's say it read 0.0875 grams. That is a very accurate measurement of the mass. However, maybe along in the experiment I've had to use this scale that's below here, and it gives me a reading of 0.1 grams. Well, how accurate is 0.1 grams? It could have had all of these several different values, but because of my scale, it can only read to one decimal point. It will round those numbers up. So using these different pieces of equipment, I'm going to get different decimal readings of the accuracy of mass. It is the piece of equipment or the number that has the least decimal places that actually will limit how you express your answer. Let's take a look at the rules for significant digits. The first rule states that all non-zero numbers are significant. And so this value right here would constitute all the values as being significant, so it would have a value of 4 sig figs. This value here would have a value of 2 significant digits. Zeros. There's several different rules to follow when there's a zero in the number. There are zeros that are called leading zeros. Leading zeros are going to be zeros that come before the non-zero numbers. They're known as placeholders, and so they are not significant. So in this number right here, the number of significant digits in this standalone number would be 3. 1, 2, 3. In this number again, this is a leading zero. This is not significant. This is the only value that would be significant. The captive, or they call the sandwich zeros, are zeros that come in between non-zero numbers. So this would be a captive zero because it comes in between non-zero numbers, as well as these values come in between two non-zero numbers. So because they're sandwiched or they're held captive, they are considered significant. So in this value you have 1, 2, 3, 4, 5, 6 sig figs in this value. And in this one, again, they're sandwiched between two non-zero numbers. You would have 1, 2, 3, 4, 5, 6, 7 significant digits. Trailing zeros have two rules. Trailing zeros are going to be zeros that come after a non-zero number. And trailing zeros are going to entail whether or not the number has a decimal point or does not have a decimal point. If it has a decimal point, those trailing zeros are going to be considered significant, and if they don't have a decimal point, they're considered not significant. So here is an example of trailing zeros. It has a decimal point. So trailing zeros with a decimal point means it's significant, so all of these zeros are counted, and this value would have 5 significant digits. 1,000. Again, trailing zeros, however, it does not have a decimal point, and so without a decimal point, those trailing zeros are not significant, and so this value only has 1 significant digit. Notice the uniqueness of this number. There's a decimal point after this. You see this once in a while in science. It means that it's an exact number of 870, that you actually read it. And so because this is a trailing zero and it has a decimal point, it's considered a significant zero. So this value would have 3 significant digits. Whenever you see a scientific notation number, however it is expressed to you, even though it may not be in the correct format, just count that as being all significant numbers. So in this one, there are 3 significant digits. I didn't have to determine that those were zeros, trailing zeros with a decimal point. It's scientific notation. They're all significant. Now this number is not written correctly using the scientific notation rules. However, that's how the number was presented to you. They are all considered significant. So this would have 1, 2, 3, 4, 5, 6 sig figs, just because it's scientific notation. The Pacific versus the Atlantic method. I'm going to approach this number from this side, from the Atlantic side, because it does not have a zero. I'm going to stop at the first non-zero number and then keep counting then on. That means all those numbers would be significant. So in this one, there would be a value of 2 significant digits. If I use the previous rules, those would be trailing zeros without a decimal, so that means they are not significant. Let's take a look at this one. This one has a period. I'm going to approach it from the Pacific. I'm going to keep going from the Pacific way until I hit the first non-zero number. And as soon as I hit that first one, count the rest of the values. Don't have to delineate what kind of zero they are, if it has a decimal or nothing. So I'm going to count 1, 2, 3, 4, 5, 6 significant digits are in that value. Again, this has a period. Approach it from the Pacific. Because it has a period, this is the first spot which I continue to count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 significant digits. These would have been captive zeros because they would have occurred between 2 non-zero numbers. And this zero over here would have been a trailing zero with a decimal point. If the rules work for you, that's fine. If you like the Pacific and the Atlantic method, use whatever method works for you. This is a scientific notation number, and that falls into the category of scientific notation. I'm just going to use the number as it is. All of the numbers are significant, so I do not use the Pacific and the Atlantic method for this one. Each of these express 300. But if you take a look at this 300, if I use the Pacific and the Atlantic method, I'm going to approach that number from the Atlantic side until I hit the first non-zero number, and that continue on to count. There are no more numbers to count, so I have 1 significant digit in this value of 300. In this one, it has a period, so I approach it from the Pacific and keep counting. This would have a value of 5 significant digits. The next one is a scientific notation. All of those numbers are significant, so this has a value of 2. This one has a period in it. Trailing zeros with a period means that those are significant. If I approached it from the Pacific, I would have started there and counted on. This has 3 significant